Today we're talking about similar figures, and similar figures have the same exact shape, but they're different sizes. In similar figures, what is true about the angles and what is true about the sides? For the angles, they're congruent. So even if they're different sizes, their angles are still going to be the same size. And let's see, sides. The sides are proportional. So for number 3, given triangle ABC is similar to triangle DEF, complete the proportions by filling in a line segment or an angle. So alright. I would prefer that you use 2 different colors, and I don't think I have 2 different colors on my toolbar, but this says triangle AC or line segment AC, okay, over DF. So there's DF. So we could say that this is the big triangle and this is the little triangle. So then on the big triangle we have BC. So then if you look at the little triangle, which line segment is just like BC? Okay, well EF. Alright, so then for B, let me erase those. So then for B, it says AB. AB over AC. Okay, so this is going to be big side, and this one would be big bottom. Alright, so now we have to look, so we've already done AB and AC, so now we have to look at DF. Okay, so then that's on the bottom. So now we think, okay, the big side, so then this was the little bottom. So then the top has to be the little side. Because AC is just like DF. So what's just like AB and the little triangle? You're right, DE. All right, moving on to C. If angle A, and that's a congruent symbol, if angle A is congruent, so angle A is congruent to what other angle in the little triangle? All right, so what's in the same spot as A? D is. So angle D. All right, so now looking at the next one. We have angle F is congruent to what? All right, so angle F is here. Well, where is F in the big triangle, or what's just like F? Angle C. All right. All right, so now we're on number 4, and this is where you have to set up a proportion and solve for the value of n. So I think it's easiest to start with what you know, okay? We have 10 and we have 8 on the big triangle. So on the big triangle, we've got 10 over 8. And now we're going to talk about the little triangle. And we've got 6 over n. Well, I know that 10 is just like 6. 10 is just like 6 because they have that 37 degrees in the same spot. I know that 8 is just like n because the 50 degrees is in the same spot. So if I have 10 over 8, well, what's just like the 10? The 6. And what is just like the 8? The n. So now I'm just going to solve it like we always solve proportions. I'm going to cross multiply. 8 times 6 is 48. And then 48 divided by 10, because I always divide by that leftover number, is 4.8. So my answer to that one would be 4.8. All right, looking at number 5, we're again solving for the given angles if the two parallelograms are similar. So, angle X. Well, let's look at what's alike. So, I know that B is just like X. They're in the same spots. The shapes are formatted the same. They're just different sizes. I know A is just like W. I know C is similar to Y. And D is similar to Z. So remember, the angles are congruent. So for angle X, that's what I'm looking for. It's got to be the same as what it's like. So we know that X is just like B. So they're going to have the same angle measurement because the angles are congruent. So angle X is also going to be 145 degrees. All right, we said that Y is just like C. Well, what's the measure of angle C? 35 degrees. So then that's also what angle Y is because they are congruent. They are the exact same. Okay, how do I pause? All right, so now we're almost done with this paper. Okay, we have that number 6 says determine if the statements are true or false about the similar triangles. So again, I suggest using 2 different colors or multiple colors and really thinking about what it's saying. So this says line segment AE, which is right here, corresponds to BD, which is right there. So yeah, those two are in the same spots. So whether or not you see it, there are actually 2 different triangles here. You have triangle AEC. Okay, then you also have triangle BDC. So you do have 2 triangles there. And if it's difficult for you to see both in that one space, then I'm going to suggest that you draw them separately. So we know that we have 2 triangles. We have AEC. And we also have triangle BDC. So again, if it's hard for you to see them all right here, draw them separately. That may help you. So yes, AE does correspond to BD because they're in the same spot on both triangles. So the next one says, does ED, E to D, does that correspond to DC, D to C? It does not, because if you think about the 2 triangles being separate, we had triangle AEC, and we had triangle BDC. Well, there is no A or ED in our original triangle. So DC, which is right here, would correspond to EC, not ED. So this one would be false. Okay, so now let's think about the next similarity statement. Oops, I thought it was on eraser. All right, so angle E is congruent to angle D. Absolutely, they're both 90 degrees. All right, so the next one is where it gets tricky. It says CB, and this is where it might help to draw those triangles separate. So we've got CB, okay, so C to B over CA. So we've got the top of the little, and then we've got top of the big triangle. Okay, so CB is the top of the little, and CA was top of the big. So now that has to equal BD. So now BD which is the side of the little. And so if we're talking about the side of the little, and that was BD, then we've got to be talking about AE because that's the side of the big. So yes, that is a true statement. And the last one says CD. So CD. Okay, so we've got the bottom of the little. And then CE. Okay, CE is that whole bottom of the triangle, the big one. So we've got the bottom of the little over top of the bottom of the big. And I'm just going to write it over here. We got bottom, little, over bottom, big, equals AE. Okay, so AE is the big side and then we've got BD. BD is right here, which would be side of the little. This does not match up. Because if you have bottom little over bottom big, then little has to be in the numerator. And this says big, so that would be false. All right. Moving right along to the very bottom. Wow, number 7 looks crazy. So this is where you have to think about what you're looking for and what you know, okay? So we know we're trying to solve for x. So I'm just going to go ahead and make my proportion because I know I've got to set that up. So if I'm looking for x, I like to stay like with the big triangle first, or the little triangle first, or the bigger little second. So what is just like x? Okay, 8. So my first fraction is going to be all about the big triangle. My second fraction is going to be all about the little triangle. So now I just need to choose something else from the big triangle. Do I want it to be the bottom, which is 12, or the top, which is 20? I'm just going to go with 12. Because remember, my first fraction is all about the big triangle, and I'm looking to solve for x. So I went ahead and put my x right here, and now that looks messy. Okay, and I put 12 for the bottom. So what is just like 12 in the little triangle? 6. Okay, so now we're just going to solve these just like normal. Okay, so we're going to cross multiply 12 times 8, and we get 96. So the 96 divided by our leftover number, which is 6, equals 16. So 16 is what my x equals. And I could also look at this backwards. 8 times 2 is 16, 6 times 2 is 12. Okay, so this is just like your little basic introduction to similar figures. We're going to talk more about this in class. Make sure you have all this written down on your note sheet. I will be checking your note sheet.